All right, so the first examples that we're going to look at are determining whether from a table a function is exponential, linear, or neither. So let's take a look at number one. So I see I have some x values, -1, 0, 1, 2, and 3, and I've got some y values, 0.4, 2, 10, 50, and 250. So what I really want to know is I want to know what the pattern is between these numbers. Am I adding, subtracting, multiplying? Am I dividing? So sometimes when there's decimals, I look a little bit lower in the table where there's some integers that are just a little bit easier to work with and to see the pattern. So from 2 to 10, I know that I could have two things happening. I could be adding 8, or I could be multiplying by 5. So before I decide what the pattern is between these two numbers, I'm going to also look to see with the pair of numbers below it. So 10 to 50, I could be adding 40, or I could be multiplying by 5, which kind of fits that pattern that I was talking about up here. So to get from 2 to 10, I could be multiplying by 5. From 10 to 50, I'm multiplying by 5. And then just to double check, I want to say, all right, well, is 50 times 5 going to be 250? Well, yes. So that must mean that all the way down my table, I'd be multiplying my y values by 5. And then I'm going to go back up here and say, okay, just to double check, 0.4 times 5 does give me 2. So if this is all multiplication by the same factor all the way down, this table is actually an exponential function. So let's look at the next one. So I see I've got the same x values, but my y values are a little bit different here. So I'm going to start going down my values. And I have some negatives going on here. So if you don't like working with negatives too much, you can kind of move down to where your positive values are. So I'll work with the +1 and +4 just because they're easy values. So to get from 1 to 4, I could be doing two things. I could be adding 3, or I could be multiplying by 4, because 1 times 4 is 4. If I go back up a pair to get from -2 to 1, I would be -2 to 1 would be adding 3, which fits this pattern here. To get from 1 to 4, we're adding 3. To get from -2 to 1, we're adding 3. I'm going to work my way backwards and say, okay, does this fit for all of these pairs of numbers? From -5 to -2, I'd be adding 3. And to get from -8 to -5, I would be adding 3. So since all of these numbers are adding by the same value, this is actually a linear function. All right, and let's look at one more. So my x values here, -1, 0, 1, 2, and 3 haven't changed, but my y values again have changed. So to get from 0 to 2, um, well, 0 multiplied by anything would just be 0. So I know this isn't going to be multiplication, so this must be addition. So to get from 0 to 2, I'm adding 2. To get from 2 to 6, I could either be multiplying by 3, or I could be adding 4. Since multiplication didn't work up here, I'm just going to concentrate on the adding. To get from 6 to 12, I'm adding 6. To get from 12 to 24, I am actually adding 12. So if these numbers aren't the same all the way down, which they're not, I've got adding 2, adding 4, adding 6, and adding 12, this one would actually be neither.